We're going to talk about building intelligence, a great topic to end the conference on. What lots of amazing discussions. Are you Will?
I'm Will. Hi,
You're
Julie.
Will?
Yeah.
Nice to meet you.
Nice to meet you.
Do you want to intro your panel?
Yeah, I'll stand at the podium.
Yes, okay.
I will. Thank you very much. I have the pleasure of moderating the closing session, so thank you for coming. I'm Will Townsend. I am an industry analyst, and I manage the networking and security practices for my firm, Moor Insights Strategy. We're a smaller, we kind of call ourselves a boutique firm. The average analyst on staff has over 30 years of industry experience, so I spent my career, started at Dell after graduating from the University of Texas, go Longhorns in the March Madness, and spent 30 years doing that, and I've been an analyst for the last 7 or 8 years. So I'm happy to be here. So what I'd like to do is allow each of the panelists to introduce themselves, and after that, each panelist is going to present for 5 to 7 minutes, and then we're going to get into the topics. So with that, I'm going to start with you, Bob. Why don't you introduce yourself?
Hi, I'm Bob Blanchard. I'm with Klika-Tech. I'm the manager of business development for the Americas. At Klika-Tech, we, of course, ideate, co-create, and innovate with any of our customers. We're primarily focused on back-end development, device coding, firmware, those types of things. That's our real wheelhouse. But as far as I go, 40 plus years in the industry. Started dabbling in IoT probably about 5 or 6 years ago while I was working as an enterprise architect for a major retail chain, and saw that there was this opportunity for cool devices in stores. And the rest sort of took off from there. It became a career, and the last 5 or 6 years I've been focused completely on the IoT industry and have experienced quite a lot, as far as what works and what doesn't, and how LoRaWAN, I believe, solves a lot of the problems that we experienced in the past that we can leverage the power of this to move forward.
Thanks, Bob. Kausik?
Thanks, Will. My name is Kausik Dey. I'm the director for software engineering in AvalonBay communities. I'm responsible for digital transformation, whether it's cloud, whether it's IoT. I started my career with healthcare, and then last 25 years I've been in different industry, like healthcare to insurance, then finance, then accounting, and then finally last 3-4 years I'm working in real estate. My experience with IoT is probably 3 years, and specifically with LoRaWAN. And we are doing lots of good things, which will be coming in next couple of minutes. And I'm on LinkedIn, so any question, any connection, feel free to find me in LinkedIn. Thank you.
All right, thank you, Kausik. Stefan?
Yeah, hi, Stefan Lindgren. I'm CTO of Nordic Propeye. And if that is a new name of the company, it's a rebrand of the TalkPool IoT part. So same company, just a new branding of it. TalkPool has been around, or Nordic Propeye has been around in the IoT space since 2015, working with IoT end devices as well as solutions. And we are very much focused on smart buildings with the sub-metering and energy optimizations. And yeah, I will talk more about that a bit later. Based out of Europe, and most of our experience are from Europe, but we are now moving a lot into the US markets as well, especially around the air quality and energy. So excited to be here.
Thanks, Stefan. And last but not least, Joel?
Yeah, thank you. Joel Berntsen. I am from VUtility. I head up our marketing team as well as channel and partnerships. Been with the company about 2 years. We are a real-time energy monitoring solution provider that is based on the LoRaWAN tech stack. We develop and manufacture our own devices and try to leverage the common infrastructure of LoRaWAN to deploy at scale. I'll talk more about some of our products, but this is one of them. It's called the Hot Drop. It's a wireless, self-powered, non-intrusive, instant install sub-meter. So installing those for a variety of use cases, providing real-time data and insights behind the meter.
Great, thank you, Joel. Well, we're going to start with Bob. I'm going to hand the clicker to you, sir, and
right.
let you drive your presentation.
Okay. Well, obviously, we're going to be talking a little bit about solutions for smart buildings, which I think is kind of it's a broad subject, right? There are a lot of different buildings that can benefit from being smart. I'm personally going to focus a little more on multifamily homes, and possibly some of this would relate directly to a lot of things here in the Orlando area. For example, big resorts, hotels, things like that would also be appropriate for some of the topics I'm going to talk about. So the first thing I wanted to do, I wanted to kind of talk a little bit about, is it okay we stand up?
Yes, sir.
Yeah, okay.
You can stand at the podium if you
All right,
like to.
well, this is fine. The first thing I always like to kind of talk about, what are the problems you face whenever you're trying to design a smart building, right? And what are some things you have to consider? And one of the big ones is the building itself. Building structure has a lot of impact on how radio frequencies are going to work through it. You know, if all of our buildings were made out of cardboard and paper, it would be pretty easy for us to put radio signals through there, but they're not. They're made out of steel and concrete and things that just really don't like radio signals very well. So when you talk about solutions, and I always like to talk about the 2.4 gigahertz world, which is where Wi-Fi lives, of course, as well as an awful lot of already developed, smart devices for smart buildings. Well, what's the challenge that you face with this particular frequency? There's a lot of stuff on it right now. And it's got a lot of bandwidth, but it's a very crowded band, right? And when I'm explaining it to customers, I always like to use an analogy of a highway. We look out here, I don't know how many of you have had the pleasure of driving on I-4. There's like 6 lanes on I-4, sometimes 8. That's a lot of bandwidth. The problem is there's a lot of cars and trucks and buses in that bandwidth. And that's what the 2.4 gigahertz band looks like right now. And then when I try to explain to them what LoRaWAN is, I say, it's kind of like if there was this parallel road that was only 1 lane or 2 lanes that ran alongside of I-4, but only certain cars are allowed to drive on that road. And they're tiny little cars, there are no buses, there are no trucks, and they all can move along that road very efficiently, and they don't have the congestion problems that the cars on I-4 have. Infrastructure costs are obviously going to be a challenge you're going to face when you're doing a building. If you have to put 40 gateways in a building to make smart technology work, that costs a lot of money. Every network cable pull, every switch port, every power drop that has to be there for a gateway every 30 feet for a run-of-the-mill gateway is expensive. And when you can do the whole thing with a gateway or maybe a couple in a building or maybe one just for the property, it saves an awful lot of money. And then tenant technology. When we're talking about hotel or apartments in particular, you can't control what the tenants are doing in their units, right? So they're bringing in, and just look at all of us who are here today, right? We've probably all got 5 or 6 devices that are talking, our phones, our watches, our tablets that we're taking notes on, our computers. Every tenant's going to have a lot of that going in, and you don't have any control over what it does, what it talks on, or how it operates. What the nice thing about LoRaWAN, it operates outside of those frequencies. So, whoops, I think I skipped one slide too far there. No, I'm okay, there we go. So, just a quick graph that kind of shows the difference here between how LoRaWAN solves these problems, right? Better signal penetration. LoRaWAN will reach a lot further through a building or across a complex or across a group of buildings than any of the 2.4 gigahertz options do. You don't have any interference in the band. So the 2.4 gigahertz devices typically don't talk in any bands that LoRaWAN would be in. We're in sub-gigahertz, we're in 900 megahertz. And so you have a lot more ability to not worry about, number one, you interfering with your guests or your tenants, and B, them not interfering with your ability to collect data from your devices and get it back to where you need it to be. Less infrastructure cost, I kind of covered that. You don't have to put in as many gateways. In fact, the use case I'm going to show here, it typically is 1 gateway per property to cover all the buildings and be able to collect the data from the devices. And again, it's unaffected by the tenant technologies. It doesn't dance in the same range as their cell phones and their computers and everything else. So the use case I'm going to present, this was a product that we co-developed with our customer Quext. And it's basically an IoT gateway or IoT thermostat that works off of LoRaWAN. And the use case for us was really great. One of the big problems you have when you're dealing with multi-tenant structures or hotels or whatever is a significant number of the units are unused. You know, there's no tenants in them or there's no guests in the room. So you want to be able to do things like control the temperature so that you can maximize savings by regulating that. And so this solution worked perfectly for that. And with the low infrastructure cost of only having to put one gateway per property, and then be able to control the units that were unoccupied and leave the rooms warmer or cooler depending on the occupancy level, it gave tremendous savings to the people who own the buildings. But then when the tenants do occupy it, you can actually turn it over to them and let them regulate their temperatures through an app, through our cloud environment. So really a cool solution to solve that problem. And again, doesn't have the interference problems of the typical IoT device. One of the things I always like to bring up when we're talking about IoT in anything like a tenant-occupied building or something like that, you have to be aware of privacy. So you don't want to necessarily deploy technologies that are going to make people a little paranoid, like if they have occupancy sensors in their unit, or if you're monitoring their door locks to know when they're coming or going. You have to be very cognizant of that and have your technologies designed so that they're not impeding on people's privacy. And the way that we controlled it through the use of the thermostat was once a lease was signed, the tenant took over and we didn't have access to it. So we didn't in any way bother what they were doing. You have to create trust with them so that they understand that the technologies that are in that room are benefiting them and benefiting you at the same time without any invasion of privacy, something to be very aware of. The last thing I always want to talk about is interoperability with an IoT. This is kind of a big point for anybody who's considering developing a device or is developing a device for an enterprise class environment. The biggest challenge that we've run into, or that I ran into in my past and even going forward, is that technology isn't always designed to work with other technology. So if you're a maker and you're designing a piece of technology that's very proprietary, it's very hard to sell that to an enterprise class client. The last thing they want to do is have to subscribe to your cloud or your app, or only get their data through one screen and not be able to integrate it with whatever their building management system is so that they can integrate it with everything else that they're doing. Their maintenance staff doesn't sit around all day and look at one screen or look at multiple screens. They want to be able to look at something on their mobile phone, know that there's a problem with a unit or the property, and then be able to respond to it. So think enterprise. And the other thing that I always add on here too is multi-property management. A lot of companies own lots of properties, and they want something that's quickly portable to be able to integrate all their properties together. Typically cloud environments do that. So when you're designing your backends and the places where you're collecting that data, make sure you've got APIs available so that they can collate that data the way they need to, and even be able to support, in many cases, amenity access or the ability for a guest to move from one property to another property and have access to the same things that they should have based on their membership level, if they're a gold, silver, platinum, whatever, that sort of thing. So, and that's it for me.
That's great. Hey, Bob, very insightful. I think your point on privacy is well stated. One of the challenges with IoT is it expands the overall threat surface of a network. And you've got to ensure proper privacy and security controls in that regard. But with that, Kausik, let's hand it over to you and
Sure.
let you take us through your
Can
slides.
I use the podium?
Yeah, please use the podium.
Thank you. I think the green one, right?
Yeah. Well, Bob made it work.
The
big green one, yeah. It's not very intuitive.
Okay. That's my introduction slide, so let me go to the next slide. Not sure how many of you here knows AvalonBay Communities. So AvalonBay Communities is real estate equity trust or REIT, which has a long-term standing record of developing, redeveloping, acquiring, managing apartments in the best US markets. So we have close to 300 communities, or if I go a little detail, close to 90,000 apartments within United States. So we challenge the convention, recognize the problems as the seeds of our innovation. We generate new ideas, offer best solutions, and embrace changes at all levels. We test new concepts before we implement at a larger level. So LoRaWAN is part of that. In 2021, we started as a proof of concept. So before I go a little detail on LoRaWAN, I want to give a little bit about our digital transformation. So our digital transformation has 5 objectives. So whether it's IoTs, whether some other transformation, it's all 5 objectives. So starting with security, sustainability, cost optimization, performance efficiency, and operational excellence. So no matter what, we have to achieve these 5. And couple of implementation strategy. Availability is our key. It has to be available 24/7. Serverless. AvalonBay Communities is fully on serverless in its cloud. Why? We believe we should be spending time solving customer problems or business problems. We don't want to spend time managing the infrastructure. That's why AvalonBay completely on serverless. Event-driven, we all know. Microservices, we all know. Deploy anytime and visibility. I want to talk a little bit on these two. So probably a few years back, our traditional deployment is, it's something like we schedule the release, we deploy. No, in AvalonBay, we do deploy anytime, any enhancement, any new softwares, any applications. Our strategy is deploy at any time, in any day. And visibility, the most important thing, automated monitoring and alert. So we are here, 3 things. One is improving customer experience. Number 2, improve the profitability. Number 3, reduction on cost. So these automated monitoring and alerts helps us to improve the customer experience. In the smart building, our first implementation was smart elevators or elevator monitoring. So let me give you a little bit of background why we chose this. So we have close to 300 communities. Each community has multiple buildings. Each building has multiple elevators. So we can think like over close to 300 communities, how many elevators are there. If elevator is stopped, it impacts customer experience. If something goes wrong with the elevator, that's not good. We need to know ahead of our customer knows. Number 2, in every elevator, there is an elevator room, right? So where all the mechanical stuff is there and which pulls the elevator, like goes up, goes down. And inside that room, it has a mechanical box. So elevator room and mechanical box is very sensitive. No one should be opening unless and until there is a need for it. So that's what we tried to implement LoRaWAN as a proof of concept in 2021. And then till today, we expanded that in 6 communities out of close to 300 communities. So what we tried to achieve, If someone enters into the room, opens up the mechanical door, and if there is temperature, humidity, beyond the or outside the threshold, if there is any water leakage, we try to get the data through LoRaWAN, and then we had automated alert either to the building supervisor or to our elevator engineer that something is wrong, before customer comes to us or resident comes to us. And then we have a centralized dashboard we created to monitor the payloads we are getting from LoRaWAN. So from one place, we can see, okay, this is what the alerts are going on for this community. This is the status of the elevators for this community. This is one of my favorite slides. So sometimes I call it plug and play. So whatever sensors and gateways we implemented across 6 communities, the data or the payload, it comes to our AWS cloud. From there, we use compute, security, database, monitor, and streaming. Why we used AWS and LoRaWAN, side by side? So we created our framework, the model within AWS ecosystem. Now across different communities, we are deploying different sensors based on the use cases. So doesn't matter what end node or what community it is, data will come into our AWS framework and creates the monitoring dashboard, whether it's an alert based on the business problems or business logic. So with that, I would conclude my slide to the next gentleman.
All right, thank you, Kausik. That's an interesting use case. I never thought about smart elevators. I'm a movie buff, and it reminds me of the movie Die Hard and Bruce Willis, getting into the elevator. Had LoRaWAN been there, Bruce wouldn't have probably taken over the Nakatomi building. We're going to go to Joel, and I think he's next in order.
No, it's my slides.
Oh,
Yep.
we reordered. So, Stefan, you're next.
Yep. So I will talk a little bit about energy savings in legacy building. And the reason why we are doing this is that to compete with global heating, we need to reduce the carbon dioxide emissions, and building contribute to a huge amount of the carbon dioxide emissions. And to meet the Paris Accord, we need to decrease the energy consumption in building with 30%. And that is very easy to do. It is just to shut off the ventilation, let it heat up or cool down to whatever. But at the same time, we need to also consider the health and the comfort in the buildings. And the air pollutions in the environment is one of the largest contributors to health issues in Europe. And it's about 400,000 premature deaths due to bad air. And we spend a lot of time indoors, so the indoor air is super critical. And taking just, for example, radon gas that are existing in certain types of soil contribute with 2% of the lung cancer cases in Europe. So that is just one thing. But otherwise, you have particles and all of that. So we need to optimize both the reducing the energy consumption, and we want to increase the indoor air quality in the building. And what we're doing that is to optimize and control the building. So we connect the existing building management system. So LoRa is very easy to add, so it's not a forklift replacement, but it is something that we are enhancing the existing solution there. And typically we're using carbon dioxide sensors as a proxy if it is bad air in the building, and we need to increase the ventilation there. Then we are running, and we're also pulling out all the existing interesting signals from the BMS system. We're running that in a machine learning algorithm in order to learn how the building behaves, and taking in social data, taking weather data, and so on. So we can come up with the best way to control the building for the coming 15 minutes. And we're doing that every 15 minutes, and we're constant learning. It takes about 1 month of the system in order to learn the data from the building and how to control it. And the focus is that, okay, we need to make savings, but even more important is that we need to also keep the indoor air quality better. And especially in COVID times and similar, this was also a huge selling point as well. And this is something that we are running and doing, and we are controlling over 2 million square meters in Europe. And now we are also having some smaller deployments here in the US. And the kind of key takeaways from here, if not going into the technical parts, but rather to see why this is a fruitful business and why more people should do it. That is that adding sensors with LoRa is very easy, and the sensor gives insights to the building that is really needed. And in many buildings, there are just too little signals today to make an efficient control of it. We need to optimize both the energy and the health in order to increase the sustainability of the building. And the LoRaWAN is a very good backbone in order to add the sensors here. And the way that we are selling this is that we are trying to avoid the IT, we try to avoid the CTO departments, we're addressing the sustainability officers of larger companies and the CFOs. Because this is typically a strategic decision by real estate companies to make sure that their buildings are sustainable, so they can do, for example, green building certification with LEEDs, etc. Because that increases the valuation of the building, and also that they can getting better financing of it. In Europe, it's very common with the green bonds that both the European Union and different banks are making sure that their investments and that they are lending to sustainable projects. And just some live examples from a building, fairly small hotel and office of 25,000 square meters that has like 4 air handling units and 6 heating circuits and 5 cooling circuits. And it used to be more like an on-schedule ventilation there. After that, we installed the system and took control of the building, and after the month of learning for the algorithm, we can see that we can take away the high level of carbon dioxide levels in landscapes or in conference rooms. We could increase the temperature, and in Sweden, this was during the cold periods, so that was a good thing. But we can also making sure that all the temperatures and the air quality are within the certain limit that you want to control. And we got the savings of 20% of the electricity, 25% of the heating, and 24% of the cooling. And it's not uncommon that you both have heating and cooling in the same building, and quite often they are also competing each other. So it was a return on investment for the real estate owner of less than 1 year.
All right, thanks, Stefan. You know, I spent time with Cisco at their Live EMEA event in Amsterdam last month, and I know especially in Europe, there's keen focus around power consumption and reduction and that sort of thing, and so this is a great illustration, Stefan, I think, of that. And then also just the sustainability aspects as well, and where I see LoRaWAN really shining is with respect to sustainability. That was a theme that's carried forward from the Paris Expo that I attended and moderated a panel at last year, and continues to carry forward. So thank you, great insight. So Joel, let's go to you.
Again, I'm Joel Berntsen. I'm with VUtility. First of all, just want to give a real high-level overview of our product line. We're in the business of creating scalable real-time energy fitness trackers. These are both IoT and cloud-enabled edge intelligent devices, and everything about what we do is engineered to drive scale. It's not worth pursuing if it actually won't scale. The way that we go about driving scale is we've simplified the installation process, the maintenance, and reduced the cost of ownership by about 90% compared to other technologies. And we do that because they're self-powered meters. They report energy usage up to 1 time per minute, and then we deliver that data through APIs into third-party and partner applications. The installation is done safely and non-intrusively. We are a truly wireless solution, meaning it's not like the communication protocol is wireless and it's a hardwired piece of equipment. That eliminates a lot of the scoping complexities on the engineering side on the front end. And then when it comes time to install, we're able to do literally hundreds of devices in a single day. And using the LoRaWAN protocol has enabled us to do this. I don't think there's another protocol out there that would allow us to have the same long-range signal as well as the low power consumption, the low energy consumption to deliver the packets. Just a real high-level view of what we do. We have our sensors out on the edge at the equipment level. That information is collected and forwarded through the gateway into our cloud. We actually have quite a few sophisticated things we have to do in our cloud environment to make that data usable. And then from there, we deliver it into third-party applications or our own front-end platform. And we can work on existing third-party networks, both public and private, or we can help stand up networks to support our solution. I think the underlying principle that I want to get across today is better energy data is foundational to better building optimization. And some of the use cases that we're driving at are demand response, peak capacity tag management, load balancing, load shaping, phase balancing, and then energy savings and decarbonization. You can't solve these problems without having better granular insights. And then another huge one is on the predictive maintenance side and duty cycle optimization and maximization. And I'll get into all of these in a little bit on the next slide. Another takeaway, behind the meter visibility is what's going to deliver the Benjamins. So load balancing can deliver huge results. Up to 70% of a commercial building's energy bill is actually their peak demand charges. It's not the kWh that they consume, it's when and how it's being consumed and the volume that the utility perceives they need at any given point in time. So if your phases are imbalanced, there's a 3-phase system. If one of those is overloaded, it doesn't matter what the cumulative total of the 3 is. It's what that biggest one is that's going to drive your bill. A kilowatt hour saved is $1 earned. Demand response, being able to shed load when the utility asks for it, can have a huge payback. We have facilities that we partner with through our relationships with the software providers that are using our data behind the scenes. They're saving their customers, in many cases, hundreds of thousands of dollars annually off the building expense by being able to offset that load and shave it when the utility asks for it. Decarbonization has enormous financial benefits as well. I was looking for some numbers. In the US, commercial industrial is up about 20% year over year for energy costs. It's actually much, much higher in Europe. It's 300 and 400% higher in some countries right now in Europe. That's a major pain point that's trying to drive the bottom line and put some businesses potentially out of business. Reducing energy not only means smaller bills, it also means you're that much closer to your decarbonization goals. If you're using less, that's less that you have to offset with renewable generation. So the smaller your footprint is to start, the smaller your offsets have to be afterwards. So driving towards that sustainability goal requires behind-the-meter insights. Another really important use case is on the predictive maintenance side. The energy signature of your equipment is the leading of all leading indicators of predictive failure. So you may have something like a vibration sensor, you may have temperature sensors, different things like that monitoring different motors, pressure sensors, all of that. Those are going to be leading indicators relative to just waiting and seeing what happens. But compared to the energy signature, you're going to know much more about that equipment much earlier if you're proactively monitoring the energy profile of that specific asset. Not the building as a whole, but at that asset level. So proactive predictive maintenance increases the efficiency, reduces cost, can extend the life of the equipment. We actually have a partner, a huge part of their strategy is looking at assets on an individual basis and how they're actually performing. Just because something has a rated life of 10 years, if it's being maintained properly and monitored, it may be a 20-year asset. So understanding what those assets are performing like individually can maximize that capital expenditure budget and defer a lot of equipment replacement while also decreasing the energy usage of the assets during the life of it. It's essential for literally anything that's got a motor. So it could be HVAC, it could be refrigeration, it could be elevators. I'd love to talk with some of the other panelists about what they're doing.
Yeah.
Next slide is just showing a couple installation photos. We install in live environments, so the facility doesn't actually have to go down for us to install. We're outside of the arc hazard area, the equipment stays up, the facility stays up, and we can literally install hundreds of our meters in a single day. That completely changes the dynamic of cost of ownership. You're talking about things that would have been interrupting a facility's operations for weeks, and we're saying we're going to come in and have this all done in one day. You'll have data the same day that we're there. And that's it.
All right, thanks, Joel. I think the decarbonization aspect is interesting. I mean, every major company out there has a net zero goal, right? And it's sometimes hard to measure that, to really make a dent in that. So that was a very interesting application of LoRa. So let's get into the conversation. We've got about 30 minutes. We ran a little bit long, but it's great. That was all very insightful. And I want to start with something, Bob, you sort of alluded to when you started your presentation. And it's around the definition of what a smart building is, right? Because a smart building can mean many different things to many different people. So I kind of want to tee that up and start with you, Bob, and allow each of the panelists to kind of give their take on that. So I'll let you go.
Well, I think, obviously it starts, I think, with, looking at a couple of different aspects. Of course, to a building ownership group, or they of course want to save money. Dropping money to the bottom line is a big part of it. But I think, again, the part that I think we've all alluded to is the moving toward the zero carbon footprint, being able to save in that regard as well. So to me, a smart building is being able to put together a combination of devices and technologies that help accomplish those goals. Not only drop money to the bottom line for the whoever it is that owns the building or the facility or whatever, but also to be, obviously a better friend of the planet, and because that's going to help, whether they like it or not, it's going to drop money to their bottom line as well. I think a lot of people are very conscious in that area, and I think that it helps drive it there. And it can be a lot of different things. It's, I talked about a thermostat, but in reality, it's not uncommon to have a lot of different types of device that are helping to accomplish all these things, and more emerging all the time, which is exciting.
Yeah, Kausik, what do you think?
Yeah, absolutely. I completely agree with you. So we started with solving customer problems. So we want to know ahead of customer if there is a problem. Okay. So for example, let's say if we go with the elevators, right? So we have close to 300 communities, probably more than 1,000 elevators. And if I take an example, let's say downtown Brooklyn, our AvalonBay, which is like around 64 floors. If the elevator is not working during the working hours, it will be a mess.
Yes.
We want to know, if something goes wrong. If someone unauthorized goes inside the elevator room, our supervisor, building supervisor, wants to know ahead of time so that he can check, hey, who goes inside? So now coming back to solving the customer problems, LoRaWAN, like mainly LoRaWAN technology, helped us to create the POC and then implement it across multiple communities.
Mm-hmm. And I think there may be a misperception in the market around LoRa being great for proof of concept and not necessarily production. Kausik, I think you did a great job of demonstrating that's certainly not the case. But Stefan, would love to get your input on this topic.
Yeah, I would put certain characteristics to being smart, that is both that it is something that you can monitor, so you can see things, that you can learn from the data, and that you break up the data silos, so it's not locked in with the BMS vendor, but it is the service provider, and you're able to adapt and adjust, and with, for example, the LoRa infrastructure, you can very easily see, okay, I have problem with fire doors that they are open when they should be shut. Okay, I can easily add sensors to address that. So I think it's unleashing the data and visibility and able to control the building.
Yeah. Joel, what do you think?
Yeah, I think for me, a smart building allows you to, depending on the system, either control, have visibility to monitor, and have insights to the operations of things, so you can manage the building more intelligently. There can be an automation component to it as well, but I think it doesn't necessarily mean that everything's controlled. I think there are certain things that you still want that human intervention when
Sure.
you're going to change something, but at a minimum, having insights to be able to monitor and manage things more proactively. I also think it's getting towards, Bob, what you were talking about, that single pane of glass. No one wants to be having to go multiple places.
Right.
I came out of the smart home space several years ago before I was in VUtility, and I use the analogy, no one's looking for a multiple personality disorder home. So you want to have the same thing in your commercial buildings as well. It's the fewer systems that you have to go to manage it, the more those communicate and interact with each other in a way that simplifies the operations of the building. That's the ultimate goal, because you're trying to scale the resources on the human side by making the intelligence in the building do the heavy lifting.
Well, because if you don't simplify it, if you don't have that single pane of glass, then you drive OpEx through the roof, right? And it's self-defeating from my perspective. So, but the second topic I want to get into are other use cases. So we've talked a lot about energy management, monitoring, alerting, that sort of thing. That's clearly a strong use case. But let's talk about some other applications. And Joel, let's start with you, and we'll just kind of move back down.
I think that ultimately there's value as you combine the data from different sensors, provided it's coming through that unified interface. So my energy data is enhanced greatly by having carbon dioxide being measured in the same building. It's enhanced by having other sensors in place. So having a multi-sensory building, that's really the goal of, from a digital twin perspective, I think it's working towards that, and then you can run scenarios and, basically predict outcomes. Those predictions are only as good as the information coming in. So the more things you can account for, some of those are third-party sources, outdoor weather, all that sort of stuff. You want to be able to not only see what's happening in the building in real time, but then also model scenarios and be able to make investment decisions for the building based on those predictions, and be able to see the results actually match up to what you predicted.
Yeah, and it's all about business outcomes, right? So, Stefan, you talked a lot about, pollution, monitoring, sustainability. What are some other use cases that you think are applicable for smart building?
Yeah, in general, I would say that data is a key resource for buildings, and it is not just something that the technician is working. It is something that all the in the C-level are looking at. For example, to providing the sustainability reports, you need to know how much energy you're consuming in order to do the green building certification. You want to do that automated with the online sensors, not doing manual measurements or trying to fix something once a year to just comply. So I think all of this, putting the getting the data up to management level to give useful information is really key.
And I think if you can do that successfully, then there are going to be use cases that just sort of organically develop, from my perspective. You might have some preconceived notions on what you want to do, but when you have access to the data and you have the APIs flowing, I think it sort of opens up, new opportunities for you.
The same data certainly solves multiple issues.
Yeah, for sure, for sure. And so, Kausik, beyond smart elevators, which I think are super cool, I got educated today on that. What are some other things that you're using LoRaWAN for potentially within AvalonBay?
Yeah, that's a very good question. So there are a couple of use cases we are exploring. One of the POC is almost done. So one of the use case, we are using the geolocation. So what we are doing, we are combining LoRaWAN with AWS. AWS has another product called AWS Location. So it creates the geofence. So based on the longitude and latitude, it creates the geofence, and you have your LoRaWAN geolocation. So it can track within the geofence, like where are you? Are you going outside the geofence? You are inside the geofence. So there is one we are exploring right now. We completed the POC, and there is one more is right now we have, over close to 300 communities that are parking space, right? So we are trying to, we are exploring the solution of the parking management, how many slots are free, how many slots are, occupied, so that, and again, data is the key, data has the value. When it comes, then we are, creating whether it's a business dashboard or customer-facing dashboard, alerts, those kind of things. So those are the main two use cases we are, apart from, whatever we implemented, like water leakage sensor, temperature, door sensor, acceleration sensor, those kind of things.
I think the smart parking thing, I mean, you talked about improving customer experience as one of your main tenets.
Correct.
That's huge. If I live in an apartment complex and I'm coming home at night, maybe I've been out a little too late, and to be able to determine that there's going to be a parking, space in the garage, I think would be key, right? So I think that's fantastic. And then finally, Bob, what do you think? What are some other use cases?
Oh my goodness. Well, one of the ones that we're actually working with a customer on right now, which is exciting, is we're actually trying, again, using geolocation services within LoRaWAN to track medication use for sensitive medications that are addictive. We're able to capture the data when a pill pack was popped and tell where, when, how many, all of that, and send it back via LoRaWAN, get it to the provider as well so that they can monitor that and prevent addiction situations and things like that. So those are some of the other things, as well as some other sensors within the oil and gas industry that we're currently working with customers on to detect different types of gas and things like that.
Interesting.
Yeah, geolocation is very powerful. Like it's connected to so many use cases.
Oh yeah.
And it can help solving customer issues.
Yeah.
In fact, like how far you are, how long it will take to reach there. There's so many use cases, connected to the geolocations.
Oh yeah, I mean like location. If I think about like in Orlando, hospitality, having sensors that determine, proximity and density, so that if a line grows at the front desk like it did this morning for me, they can bring extra people in there to line bust and break it up, right?
Yep.
That can be accomplished with things like BLE, beacons, but it's not as accurate, right? And there's the congestion, and that's a good segue to the next topic I want to talk about. And it's like, so, I mean, there are lots of different options for connectivity within a smart building. You've got beacons, BLE. I think your slide, Bob, you put some things up there, but one of the challenges is congestion. And I liked your analogy about the cars. I hate traffic. But that was really interesting. But so from your perspective, how does LoRaWAN really shine? Obviously less congestion, but are there other aspects of the platform?
Yeah, of course. Well, obviously the building penetration capabilities, it's not nearly as impacted by structural limitations as other higher bandwidth protocols are. And the simple fact is most of the devices that we're using in smart buildings, their data amounts are fairly tiny.
Right.
So they're the perfect use case for LoRaWAN. The biggest misconception I think that customers have of LoRaWAN is what it is.
Right.
They think that it compares to like Wi-Fi or something like that. And so our job, quite frankly, when we're trying to sell to those customers is to really help to try to convey to them, which is why I use that analogy, because it's something that people can relate to. I mean, I think a mistake we all have as engineers and such, and I do this all the time, I make the incorrect assumption that people really understand what I'm talking about when I talk about bandwidth. And they understand what wireless is, but they don't understand that all wireless is different.
Yeah.
And so we have to make sure that we tell them that the use case for LoRaWAN is for devices that send very small amounts of data through walls and buildings at very long distances and do it very well, but don't try to stream video through LoRaWAN.
No, narrowband won't cut it. And I think another superpower that LoRaWAN has is scale, right? And so Kausik, you and I were talking before the panel, and you touched on this, the integration with AWS and LoRaWAN. So I want to ask you about that and how you've been using LoRaWAN data in AWS to leverage monitoring and alert capabilities. So.
Yep, this is a very good question. So what we did in our transformation journey, when we started this proof of concept, the first thing we implemented is the AWS serverless framework. So it's in the middle. Now we have close to 300 communities, right? And we'll be bringing more and more LoRaWAN end nodes. So data will be coming to our AWS framework through IoT Core. And again, everyone knows AWS supports LoRaWAN gateway and the end nodes. And then we created, it's a time series data. So it comes as a time series data. And then what we do, we enable all the business logic for dashboard. Okay, we need to see across all the communities, what is the status, what is the health of the elevator, what is the current temperature in the elevator room, is there any leakage in the basement or in the parking? So we implemented all these business logic within the AWS ecosystem, and a centralized dashboard across all the communities, and supervisor can click on, okay, it is my community, let me see what's going on here.
Yeah.
And then alerts. We enable certain alerts to go to supervisors and certain alerts to go to the maintenance engineer, right? If something happens for say, and we need maintenance engineer, he or she will get it like immediately, near real time. So they can prepare, okay, I need to go to this community, something is wrong there. That's how we leveraged LoRaWAN data into AWS framework to create the dashboard and the alerts.
Yeah, super insightful. I know, Stefan, you wanted to address, kind of the economic rationale for even making a building smart, but I'd also like you to expand on that a little bit and talk about how LoRaWAN kind of facilitates that.
Yeah, so I would say in Europe, LoRa is starting to getting kind of de facto standard in buildings. And we trying to talk as little as possible about LoRa as a technology, but rather talk with the kind of the CFO, the sustainability managers, what we can provide with the technology or with the solutions there. And the most important for them that it is an open standard, so it's not any lock-in effects. You have the security, and it's super economical. But otherwise, except for those parts, that they don't really care. What they really want is the solutions, the savings, right, the benefits for it. So yeah, we trying not to be techie, even if we are, but rather to talk with the right decision makers, because a lot of things that are scaling and that is successful, it is a lot of the kind of boring IoT parts. It is meters, it is temperature sensors, it is carbon dioxide sensors. Those are the scaling ones because that is where you have savings. So and that is what make this a de facto standard as the wireless alternative in buildings.
Yeah, and I think most customers want a desired business outcome, and to your point, they don't really care how they get there. But LoRaWAN does have some, I'll keep calling them superpowers. And Joel, I want to ask you, what other superpowers can you think of that LoRa brings to the table?
Yeah, I think for us, we had a design challenge in mind that we were trying to address. Energy monitoring has typically been gated by the cost of ownership for these large complex systems, and that prevents it from really getting adopted downstream into a lot of smaller buildings, as well as how deep in a building you actually go. Mm-hmm. And to really new construction, there's a ton of smart stuff that goes into new construction. Right. That's a minuscule amount of the buildings that are out there. So if we're serious about addressing from a sustainability perspective, if we're serious about reducing cost of ownership and driving more to the bottom line, if you have those outcomes in mind, you have to find a way to address the existing building infrastructure. So we said, set out and said, we want to be inside the meter, or we want our meters to be inside the panel. We want them to be self-powered, and we want to be able to provide very, very frequent data transmissions. So your utility meter is outside of the building. It's 60-minute or 15-minute data. A lot of other systems that are wireless, from a communications perspective, have to have a box sitting outside the panel. They're battery powered. They transmit every 15 minutes, every hour. Yeah. We wanted much better data to drive better outcomes. And so LoRaWAN was really the only way that we could punch our signal out of the panel. We're still getting 1,000 feet away to a gateway inside pretty complex buildings. multiple stories away, and we're able to do self-harvested power on a minute-by-minute basis to transmit. So we wouldn't be able to do those things without LoRa. LoRa is really fundamental to what we are able to deliver.
Yeah.
I think our biggest challenge was how do we work around the packet size, and there's quite a bit of engineering work our team's done to optimize around that. So we probably use LoRaWAN very differently than some other sensor categories, but what we do would not be possible without LoRaWAN.
Yeah, awesome. Well, we're wrapping up. I've got a final topic that I want to discuss, and it's sort of around just the whole journey to a smart building, right? So I imagine there are a lot of lessons learned along the way, and I'm wondering if each of you could provide your thoughts or your insights on, lessons learned or the best way to approach a smart building, because I think, for a lot of customers, where do they start? It kind of gets back to the question, what is a smart building, right? But Joel, maybe we'll start with you.
Yeah.
Yeah.
I think no one's going to solve this by themselves. No organization is going to take this on by themselves. So for us having that sort of partner first mentality, that's really how we go to market. We can try to solve very specific use cases end to end, but a lot of the things that people want to address, we're never going to be specialists in that. So what's our expertise? What's at our DNA? It's getting the data that no one else can get and being able to deliver that into other platforms. So we rely very heavily on analytics partners. We collaborate with other sensor makers. It's like we want to stay in our lane and focus on what we can really excel at and be an enablement to these bigger solutions. I don't think anyone's going to be able to take it all on, and building walled gardens doesn't help solve the problem or accelerate the success.
It's actually a negative in a lot of ways, and I think best of breed and the ecosystem that the LoRaWAN Alliance has built is pretty compelling. So Stefan, any lessons learned that you'd like to share?
Yeah, I would say that go for what makes economical sense as a building owner. It is energy consumption, like Joel's sensors can provide. It is also the keeping the tenants happy with having good indoor air quality. So I would start with the big things there, and then we have the huge ecosystem of good sensors, so everybody can then easily add additional use cases and so on. But it is important that start with what makes economical sense, I would say.
Okay, great. And Kausik, what are
Yep.
your thoughts?
So for LoRaWAN, the most important thing for me, you don't need huge budget to do a proof of concept. You have.
We were talking about that before the panel, right?
Yeah.
Yeah, it's like a factor of 10x less, right?
Right. So I know, a couple of examples in non-LoRaWAN where there was, just for the proof of concept, there's a big budget we had to allocate. But LoRaWAN, simple budget, probably less than $1,000. One use case, one sensor, one gateway. And, it's good to see that, today I went to the marketplace. There's so many, different vendors came, and, big thanks to the vendors who came and showcased their, and that opened up lots of use case to solve. So LoRaWAN supports a couple of things. First of all, we don't need a big budget to do a proof of concept. One, the proof of concept is, good. We can expand like community by community by community. That's number one. And its payload serves two things. One is it solves the business or customer problems or the pain points. The another thing LoRaWAN supports, the health of the end node. Your battery is low, tempered, those kind of things. So, all inclusive, this is the perfect solution for smart building.
Yeah, and I like the pay as you grow, right? I mean, especially with what you do, you're going to be building, new communities over time, and you need a platform that you don't overinvest in on the front end, that you can grow with as you need it. So, well, Bob, you get the final word, my friend. So why don't you close the conversation?
Oh my goodness, from a lessons learned perspective, I mean, I can say that, probably the most difficult challenge, I'm sure everyone in this panel has probably experienced this. Whenever you're presenting this concept of LoRaWAN to a new customer, you're confronting the sins of the past, so to speak. The customer has been probably experienced some other technologies that didn't work out for them. And the reason that they've reached out to you to begin with is because whatever they're doing currently isn't working for them. Yeah. And so what we've experienced, in Klika-Tech, for example, we do so much work with AWS in particular. That's really our wheelhouse. We're on the verge of becoming premier partners with AWS.
Oh, congratulations.
But at the same time, it's about being able to take this information that we're gathering from this stuff to make a smart building, right?
Yeah.
It's about taking information and putting it into something that's very consumable and actionable to a client. And that's really what they're after at the end of the day. And doing it in a way that is conservative to their bottom line. And so for us, for example, just off the top of my head here, say for example, you're in an apartment building that has smart technology and it has a bunch of sensors, and we have water sensors and we have smart light bulbs, and you have a technician who's out working on changing a smart light bulb, but there's a severe water leak in a unit. We want to be able to prioritize that data to get that technician to respond to the most important data first, right? So it's about being able to demonstrate to our customers that we understand their pain points and that we know how to solve those pain points. And the best way I've found that we can do it is by showing them examples of what we've accomplished with our past clients and being able to show them instance after instance after instance where we understand what your pain point is and here's how we have fixed it in the past. There's nothing more powerful than being able to show them a track record of success. And that's what we strive for.
I agree. Proof is in deployment, proof is in success, and when you can show successful deployments, I think that's huge. So, well, hey, I want to thank all of you for a super insightful discussion. I learned something new, smart elevators, Kausik, so keep up the innovation. We have about 5 minutes left for Q&A, so don't be bashful. If there are any questions, we have the mics right there. We'll give you a few minutes. Oh, can we turn the mic on? Or
It doesn't work. Oh, it does.
There it is.
Thank you so much. This was such an insightful, and I loved how the panelists connected with how it's going to make the humanity, health and decarbonization, everything. So I'm very much on board with what you say. So my name is Danny Dig. I represent University of Colorado. I'm asking for each of the panelists, how do you work on R&D? What's the ecosystem of partnerships? I think you were mentioning about. We can't go alone, like we can go a lot further when we go with others than when we can go alone. We can go fast when we go alone, but we can go a lot further when we go. So when you look at R&D, can you talk about how you partner with other institutions? What works? Do you, any insights that you have on how you choose?
So R&D, anyone want to take that one?
Yeah, so our organization, we have a great team internally. We do supplement with some outside help. A lot of it comes down to getting the feedback from the market, what's important and what's not. So we try to be very sensitive to what our partners and their customers are saying their needs are and their use cases are. And then for stuff that's in the market, there's ongoing iteration and improvement. I think that's one thing, sort of a recurring theme with IoT generally. People expect things to get better over time. It's not like you have a device that you create and then 15 years later it hasn't changed. There's this expectation that you're going to be able to continue improving and driving additional insights through the same technology. So there's an iterative component, and then I think from an ideation and new development perspective, it's really understanding what the market needs, what the gaps are. We have our own team internally, but then it's everything from some outsourced design partnerships that we have to manufacturing partners that can produce something that the market will accept from a cost perspective at scale. So,
great. Any other feedback from the panelists?
Sure. So one of the things that we pride ourselves in, one of our core pillars really is co-creation with our customers. And the way that we do that, we start our engagements with our customers, with our R&D team. And we not only listen to what their idea is or what they're trying to create, but we also do the market research with them and go out there and make suggestions and kind of offer insight and advice to them to say that you might go this way, or here's a potential competitor that's doing this, but you might try doing it this way. So for us, it's very important to be involved in the co-creation process while we're going through the R&D phase of any product that we're helping a customer develop. And that goes on literally through the whole engagement. Once the team is put together, that just never stops. The customer may come to us and keep expanding on it and growing with it, and you just have to be flexible and be willing to go ahead and move with the customer in the direction that they see their solution going. Of course, you don't want to have the never-ending project either, but at the same time, there's just a way to do that it kind of synergizes between the customer and whoever's working with them to be the experts and implement it.
I actually have a question. So when you do a custom developed project with a client, does that intellectual property then, so can you blueprint that and leverage that for other clients, or does that IP become the ownership of the client, or how does that work?
Usually it's the client's ownership. Okay. Obviously, I don't think there's any two projects that are the same, right?
Sure.
But at the end of the day, normally what we do anyway is it's usually just the client's IP.
Okay.
And we help them co-develop it. I don't know of an instance where we've actually tried to hold IP. That's just really not in our business model.
Got it. Awesome. Any other questions? Well, with that, we want to thank you for attending the last and the best panel, in my humble opinion. And I hope everyone had a great event. Thank you.